Good morning students. 12th Maths, Chapter 2, Complex Numbers. Next topic, modulus of a complex number. So modulus of a complex number. So complex number is it equal to x plus iy. So the formula for modulus of a complex number is modulus z is equal to root of x square plus y square. So this is the modulus of a complex number. Modulus z is equal to root of x square plus y square. Let us see an example. For example, first one, modulus I. So modulus I means have the only imaginary part. So root of x square plus y square, that's equal to root of x value is 0, y value is coefficient of I, that is coefficient of I is 1. So 0 square plus 1 square, that's equal to root of 1, that's equal to the value is 1. Second example, so modulus minus 12i equal to root of x square plus y square is equal to root of, so x value is 0. Here only have the imaginary value. So x value is 0, 0 square plus y square, that is y value is coefficient of y minus 12. Minus 12 the whole square, that's equal to root of minus 12 the whole square value is 144. That's equal to, so the value is root of minus root of 144 value is 12. So third one, modulus 12 minus 5i, that's equal to root of, x value is 12 and y value is minus 5. So 12 square plus y square, y value is minus 5, the whole square, that's equal to root of 12 square value is 144 plus 5 square value is 25. 25, that's equal to root of, if we add 144 plus 25 value is 169, that's equal to root of 169 value, so root of 13 into 13, that's equal to, if inside the root if you have same values, it can take one value outside, that is 13. Let us see the properties of modulus of a complex number. Properties of modulus of a complex number. So first one, modulus z is equal to modulus z bar. So second one, modulus z1 plus z2 less than equal to modulus z1 plus modulus z2. Third one, modulus z1 into z2 is equal to modulus z1 into modulus z2. Fourth one, modulus z1 minus z2 is greater than equal to modulus z1 minus modulus z2. Fifth one, modulus z1 divided by z2 is equal to modulus z1 divided by modulus z2. 2. Sixth one, Z modulus Z power n is equal to modulus Z the whole power n, where n is an integer. Seventh one, real part of Z is equal to modulus Z. Eighth one, imaginary part of Z is equal to modulus Z. These are the 8 properties of modulus of a complex number. So first one, modulus Z is equal to modulus Z bar, modulus Z1 plus Z2 less than equal to modulus Z1 plus Z2. So modulus Z1 into Z2 is equal to modulus Z1 into modulus Z2. Modulus Z1 minus Z2 greater than equal to modulus Z1 minus modulus Z2. So modulus Z1 divided by Z2 is equal to modulus Z1 divided by modulus Z2. So modulus Z power n is equal to modulus Z the whole power n, where n is an integer. So real part of Z is equal to modulus Z, imaginary part of Z is equal to modulus Z. Let us see an example. Example 2.9. If Z1 is equal to 3 plus 4i, Z2 equal to 5 minus 12i, Z3 is equal to 6 plus 8i, find modulus Z1, modulus Z2, modulus Z3, modulus Z1 plus Z2, modulus Z2 minus Z3, and modulus Z1 plus Z3. Solution. So first you write what is given. Z1, Z2, Z3 is given. You have to find modulus Z1, Z2, modulus Z3, modulus Z1 plus Z2, modulus Z2 minus Z3, and modulus Z1 plus Z3. First you have to write the given data, that is Z1 is equal to 3 plus 4i, Z2 is equal to 5 minus 12i, Z3 is equal to 6 plus 8i. So first we can find modulus Z1. Modulus Z1 is equal to modulus Z1 value is 3 plus 4i. 3 plus 4i. That's equal to, we have the formula modulus Z. Modulus Z is equal to root of x square plus y square. You can apply this formula here. So root of 3 square plus 4 square, that's equal to root of 3 square value is 9. 9 plus 4 square value is 16. That's equal to root of 16 plus 9, 25. That's equal to root of 5 into 5 equal to, we can take from 5 outside. So the value is 5. Next we can find for modulus Z2. Modulus Z2 equal to modulus Z2 value is 5 minus 12i. 5 minus 12i equal to root of 5 square plus minus 12 square. equal to root of 5 square value 25 plus minus 12 square is plus 144. That's equal to root of 169 equal to root of 169 value 13 into 30, the value is 169. That's equal to, we can take 113 outside. So this is the value for modulus Z2. Next we find for modulus Z3, that's equal to modulus Z3 value is 6 plus 8i. 6 plus 8i equal to root of 6 square plus 8 square. That's equal to root of 6 square value is 36 plus 8 square value is 64. That's equal to root of, add the value. So 36 plus 64, what is the value? So 10. Here 3 plus 6, 9 plus 1, 10. So that's equal to root of 10 100. So we can write 10 into 10. That's equal to, you can take one value outside. So value is 10. So this is the value for Z1, Z2 and Z3. Next we have to find modulus Z1 plus Z2. So modulus Z1 plus Z2 equal to modulus Z1 value 3 plus 4i plus Z2 value 5 minus 12i equal to 3 plus 4i plus, remove the brackets, minus 12i. That's equal to 3 plus 5, 8 minus 12, 12 minus 4 minus 8i. That's equal to, so root of, next we can use the formula, that is root of x square plus y square value. So root of 8 square plus minus 8 square. That's equal to root of 8 square value is 64 plus 8 square value minus 8 square value is 64. That's equal to root of 64 plus 64, 128. That's equal to root of, have to take LCM. So for finding the root value of 1 to the 128, we have to take LCM. So 2 here, 6, 4, next goes for 2 table, 3, 2, again 2, goes for 1, 6, 2, 8, 2, 4, 2, 2. This is the LCM value you can write here. So 2 into 2 into 2 into 2 into 2 into 2 into 2, 1, 2, 3, 4. That's equal to, so we can take, so 2 into 2, we can take 1 to outside, that is 2 into here, 2 into 2 into root 2. That's equal to 2 2s are 4, 4 2s are 8, 8 root 2. This is the answer for Z1 plus modulus Z1 plus Z2. Next we have to find for Z2 minus Z3. So Z2 minus Z3, that's equal to, Z2 value is 5 minus 12i minus Z3 value is 6 plus 8i. That's equal to 5 minus 12i. Have to multiply this minus inside. So minus 6 plus minus 8i. That's equal to modulus 5 minus 6 minus 1 minus 12i minus 8i. So minus 20i. That's equal to, we can use the formula. So root of minus 1 the whole square plus minus 20 the whole square. That's equal to root of minus 1 the whole square value is 1 plus minus 20 the whole square. So minus with minus plus 20 square value is 400. That's equal to root of 1 plus 400. The value is 401. Next, we can find value for modulus Z1 plus Z3. So modulus Z1 plus Z3. That's equal to modulus Z1 value 3 plus 4i plus Z3 value 6 plus 8i equal to modulus 3 plus, have to remove the bracket, 3 plus 4i plus 6 plus 8i equal to modulus 3 plus 6 the value is 9 plus 4 plus 8 value 12i. Then you have to use the formula. So root of 9 square plus 12 square equal to root of 9 square value is 81 plus 12 square value 144 equal to root of 81 plus 144 can add. So 4 plus 1 5. So 4 plus 8 12. Here 1 plus 1 2. That's equal to root of 225. That's equal to root of 15 into 15. So 15 into 15 the value is 225. Can calculate 15 into 15. 5 5s are 25. So 5 plus 2 7 5 1. So 225. That's equal to, we can take 15 outside. So 15. This is the answer for modulus Z1 plus Z3. Next example, example 2.10. Find the following. First subdivision, modulus 2 plus I divided by minus 1 plus 2i. Second subdivision, modulus 1 plus I the whole bar into 2 plus 3i into 4i minus 3 modulus. Third subdivision, modulus I into 2 plus I the whole cube divided by 1 plus I the whole square. Let us see the first subdivision. So first subdivision, modulus 2 plus I divided by minus 1 plus 2i. That's equal to, so modulus 2 plus I divided by minus 1 plus 2i, you can separate the modulus value. That is 2 plus I modulus divided by modulus minus 1 plus 2i. That's equal to, so is the formula root of x square plus y square formula. So root of 2 square plus 1 square divided by root of minus 1 square plus 2 square equal to root of 2 square value is 4 plus 1 square value 1 divided by root of minus 1 the whole square, that is 1 plus 2 square value is 4 equal to root of 4 plus 1 value 5. 5 divided by root of 1 plus 4 value is 5. So root 5 cancel, you will get value as 1. This is the answer for first subdivision. So the answer equal to 1. Second subdivision, modulus 1 plus I whole bar into 2 plus 3I into 4I minus 3 equal to, we can write modulus 1 plus I the whole bar modulus 2 plus 3I into modulus 4I minus 3. That's equal to modulus. So you have the conjugate, have to take the conjugate because have the property z, that is 1 plus I the whole bar means you can take the conjugate, that is 1 plus I, conjugate of 1 plus I is 1 minus I. So 1 minus I into 2 plus 3I into 4I minus 3 equal to, then you can use the formula, that is root of x square plus y square formula. So 1 square plus minus 1 the whole square into root of 2 square plus 3 square into 4 square plus, is it here? You have to write the imaginary real part first, then you have to write the imaginary part. So the real part is minus 3 plus imaginary part is plus 4, right? So minus 3 the whole square plus 4 square. That's equal to root of 1 square value is 1 plus minus 1 the whole square value 1 into root of 2 square value 4 plus 3 square value 9 into root of minus 3 the whole square, that is 3 minus to minus plus 3 square, 3 into 3 9 plus 4 square value is 16. That's equal to root of 1 plus 1 value is 2 into root of 13 into root of 25. That's equal to, so root of 2 into 13 into, we can write this 25, root 25 is 5 into 5. That's equal to root of 2 into 13, 26 into 5. That is, we can take from the root, we can take the value is same, we can take one value outside, so 5. So that's equal to my root of 26 into 5, 5 into 26. This is the answer for second subdivision. Next we move to the third subdivision. Third subdivision, so modulus I 2 plus I the whole cube divided by 1 plus I the whole square. That's equal to, so separate the modulus, that is I into 2I plus the whole cube modulus divided by modulus 1 plus I the whole square. That's equal to, so I modulus, then modulus 2 plus I the whole cube divided by 1 plus I have to take the modulus. So modulus square. That's equal to modulus I 2 plus I the whole power 3 divided by, so 1 plus I the whole square equal to, so for we can use the formula root of x square plus y square formula. So root of 0 square plus 1 square into root of 2 square plus 1 square the whole cube divided by 1 square plus 1 square the whole square equal to root of 1 square value is 1 into root of 2 square value 4 plus 1 the whole cube divided by 1 plus 1 2, so root of 2 the whole square. That's equal to root of 1 the value is 1 into root of 4 plus 1 value is 5 cube divided by root of 2 the whole square. We can write as the square root and square cancel, so the value is 2. That's equal to root of 5 into root of 5 into root of 5 divided by 2. So we can write root 5 into root 5 the value is 5. That's equal to 5 root 5 divided by 2. So this is the answer for third solution. Next exercise 2.5. First problem, find the modulus of the following complex numbers. So first question, 2 minus I divided by 1 plus I plus 1 minus 2I divided by 1 minus I. Solution. So have to find the modulus of the following complex number. So in this question, so have the LCM value. So first we have to take the LCM. That's equal to 2 minus I divided by 1 plus I plus 1 minus 2I divided by 1 minus I. What is the LCM value here? So 1 plus I and 1 minus I is the LCM here. So we can take the LCM. So 1 plus I into 1 minus I. So we can cross multiply the value. Okay. So 2 minus I into 1 minus I plus 1 minus 2I into 1 plus I. So we can cross multiply the values. That's equal to, so then we can multiply, take the product. So 2 into 1, 2 into minus I, minus 2I, minus I into 1, minus I into minus I, plus I square, plus 1 into 1, 1, plus 1 into I, plus I, minus 2I into 1, minus 2I, minus 2I into I, minus 2I square divided by can use the formula a square minus b square formula, that is a plus b into a minus b is equal to a square minus b square. So 1 square minus 1 square. That's equal to, so add 2 minus 2i minus I, here I square value is minus 1, minus 1 plus 1 plus I minus 2i, here I square the value is minus 1, minus 1 into 1 plus, so plus 2 divided by 1 minus minus 1. So after this is I square. Okay. 1 square minus I square. So 1 plus I square value is minus 1. So plus 1. That's equal to 2 minus 1, the value is 1. 1 minus 3i plus 1 plus 2, the value is 3. 1 minus 2 minus I divided by 1 plus 1, 2. That's equal to 1 minus 3i plus 3 minus I divided by 2. That's equal to 1 plus 3, the value is 4, minus 3 minus 1 minus 4i divided by 2 equal to, here 4 is there, we can take 2 outside. So 2 into 2 minus 2i divided by 2. So we can cancel this 2. That's equal to 2 minus 2i. So this is the modulus value. Okay. So you have to take the modulus. So for finding modulus of the number, complex number, you have to write the modulus value. So modulus 2 minus 2i. Then you have to use the formula root of x square plus y square formula. So root of x square, that is 2 square plus minus 2 square. That's equal to root of 2 square value is 4 plus 4. That's equal to root of 4 plus 4, 8 equal to root of, we can write this 8. If we take LCM, we will get 2 into 2 into 2. That's equal to 2 root 2. So this is the answer for this question. Okay. Example 2.11. So which one of the points I minus 2 plus I and 3 is farthest from the origin? Solution. Which one of the following points? Which one of the points I minus 2 plus I and 3 is farthest from the origin? That is, you have to find which value is farthest from from the origin. First we write the given data, that is Z. We can take Z1 equal to I, Z2 is equal to minus 2 plus I, Z3 is equal to 3. Then you have to find the modulus. So Z1 modulus, Z1 is equal to modulus I equal to, so root of, use the formula root of x square plus y square. So 0 square plus 1 square, that's equal to root of 1, that's equal to value is 1. Then we have to find Z2, modulus Z2 equal to minus 2 plus I, that's equal to root of minus 2 square plus 1 square, that is equal to, so root of 2 square value is 4, 4 plus 1, that's equal to root of 5. Next we have to find modulus Z3, that's equal to modulus Z3 is modulus 3, that is equal to modulus 3 value is 3. So you have to find, since so you got 3 values, so you can write 1 is, since 1 is less than root 5 means you will get 2 point something value, so less than 3. So just we can draw an orient line here. So 0, 1, 2, 3, 4, 5. This is real part and this is imaginary part. Minus 1, minus 2, minus 3, minus 4, etc. Here minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4, 5. Now we can plot the points here. So in the first question, Z1 value is I. I means the coefficient of I is 1. So imaginary part here. This place, that is 0, 1. Okay. Next one is Z2, minus 2 plus 1. Minus 2 in the real part. Minus 2 in the real part. This place. And 1. I, coefficient of I is 1. So in the imaginary part, this part. So minus 2, 1. So you can join this line. Next third one, 3. That is, this is the real part. So real part's value is 3. 3, 0. So you can join 2. So from here, which is farthest from the origin? So 3 is farthest from the origin. It's not closest, it is farthest from the origin. So what is the answer? Answer is 3. So the point, so the farthest point is, you can write the farthest point is point from the origin is 3. This is the answer. Next question, exercise 2.5. Third question. Which one of the points 10 minus 8i 11 plus 6i is closest to 1 plus I? Solution. So in this question, have to find the closest point to 1 plus I. So which one of the points 10 minus 8i 11 plus 6i is closest to 1 plus I? Z1. So Z1 is equal to 1 plus I. Z2 is equal to 10 minus 8I. Z3 is equal to 11 plus 6I. So for finding this, we have to find Z. First we have to find Z1 minus Z2. Again you have to find Z1 minus Z3. Compare both the values which is smaller. That is closest value means you have to find the smallest value. Okay. So Z1 minus modulus Z1 minus Z2 is equal to modulus Z1 value 1 plus I minus Z2 value 10 minus 8 equal to modulus 1 plus I. Have to multiply this minus inside. Minus 10 minus into minus plus 8 equal to modulus 1 minus 10 minus 9 plus this is I. So 1 plus 8 9 I. Then you can use the formula root of x square plus y square. So root of minus 9 the whole square plus 9I. So y value is 9 square. That's equal to root of 9 square value is minus into minus plus 9 square 81 plus 81 equal to root of 162. Then we can find the value for Z1 minus Z2. Z1 minus Z3. That's equal to Z1 value, write Z1 value 1 plus I minus Z3 value 11 plus 6I equal to modulus 1 plus I into multiply this minus inside. So minus 11 minus 6I. That's equal to modulus 1 minus 11 value is minus 10 minus 1 minus 6 is minus 5 I. That's equal to, we have to use the formula x square plus y square formula. Root of x square plus y square. So minus 10 the whole square plus minus 5 the whole square. That's equal to root of 10 square minus 10 square value is 100 plus minus 5 square value minus into minus plus 5 square value is 25 equal to root of 100 plus 25 125. So from here we got Z1 minus modulus Z1 minus Z2 value is root of 162 and modulus Z2 minus Z3 value is root of 125. Comparing both the values which is smaller. So this is the smallest value which is closest to 1 plus I. Okay. So the closest point. So comparatively this value is smaller than this value. So this is smaller value. So is it, we can write 1 plus I 11 plus 6I is closest to 1 plus I. This is the answer. While writing, you can write like this 11 plus 6I. That is Z3 value. This is the Z3 value. Okay. So 11 plus 6I is closest to 1 plus I. Example 2.12. If Z1, Z2 and Z3 equal to modulus Z3 is equal to modulus Z1 plus Z2 plus Z3 is equal to 1. Find the value of modulus 1 by Z1 plus 1 by Z2 plus 1 by Z3. Solution. So if Z1 minus Z2 and Z3 are complex numbers such that modulus Z1 is equal to modulus Z2 is equal to modulus Z3 is equal to modulus Z1 plus Z2 plus Z3 is equal to 1. We have to find the value of modulus 1 by Z1 plus 1 by Z2 plus 1 by Z3. First have to note it, have to write this note. Modulus Z the whole square is equal to Z into Z bar. You have to write it as note. Okay, so modulus Z whole square is equal to Z into Z bar. Then we can find the values. Okay, so Z modulus Z1 is equal to 1. So modulus Z1 we can square this term. So modulus Z1 the whole square is equal to 1. So we can write Z into Z1 into Z1 bar the Z1 into Z1 bar is equal to 1. You have to know 1 by Z1 value. First you have to find 1 by Z1 value. So Z1 bar is equal to 1 by Z1. This is for first case. So 1 by Z1 is equal to Z1 bar. Then we can find Z2 modulus Z2. That's equal to modulus Z2 value is 1. So we can write Z2 modulus the whole square is equal to 1. We can square this term. So what is the formula we have given? I have given Z into Z bar. So Z2 bar is equal to 1. So Z2 bar is equal to 1 by Z2. Next we find modulus Z3 is equal to 1. Modulus Z3 is equal to 1. Then you have to square this term. So modulus Z3 the whole square is equal to 1. So Z3 into Z3 bar is equal to 1. We can write Z3 bar is equal to 1 by multiplication. When it goes to the next side, goes to the next side means it is division. So Z3. So you got 3 values. So you got 3 values, that is 1 by Z1, then 1 by Z2, then 1 by Z3. Then you have to substitute the value in the given question. So in the side we can write. It is easier to find the value. So Z1 bar is equal to 1 by Z1. Z2 bar is equal to 1 by Z2. Z3 bar is equal to 1 by Z3. Then we can write the question 1 by Z1 plus 1 by Z2 plus 1 by Z3 is equal to modulus 1 by Z2 value is modulus, that is Z1 bar plus 1 by Z2 value is Z2 bar plus 1 by Z3 value is Z3 bar. That's equal to, have the property, you can take the whole bar, that is modulus Z1 plus Z2 plus Z3, the whole bar is equal to, so modulus Z, have the first property of modulus of value is given in the question. Modulus Z1 plus Z2 plus Z3 is equal to 1. That's equal to, the value is 1. So this is the answer. So answer equal to 1. Move to the next question. Exercise 2.5. Second question. For any complex numbers Z1 and Z2 such that modulus Z1 is equal to modulus Z2 is equal to 1 and Z1 into Z2 not equal to -1, then show that Z1 plus Z2 divided by 1 plus Z1 into Z2 is a real number. Solution. Same as the previous problem. So we can find the Z1 value. So for any complex number Z1 and Z2 such that modulus Z1 is equal to modulus Z2 is equal to 1 and Z1 Z2 is not equal to -1, then so show that Z1 plus Z2 divided by 1 plus Z1 Z2 is a real number. We have to show it's a real number. So Z1 Z2 is not equal to -1 because in the denominator should not be 0. That's why Z1 and Z2 not equal to -1 is given. So first we can write the given data, that is modulus Z1 is equal to 1. So already I have given the note. Z1 the whole square equal to 1. So we can write this term as Z1 into Z1 bar is equal to 1. Here we have to find the Z1 value. So Z1 is equal to 1 by Z1 whole bar. Okay. This is for Z1 value. Next we can find Z2 value. Z2 modulus Z2 is equal to 1. So we have squared this term. So Z2 the whole square is equal to 1. So Z2 into Z2 bar is equal to 1. So Z2 is equal to 1 by Z2 bar. This is for Z2 value. You know two values, then you have to substitute the values in the question. We can write these answers here. Z1 is equal to 1 by Z1 bar and Z2 is equal to 1 by Z2 bar. So write the question. Z1 plus Z2 divided by 1 plus Z1 into Z2. That's equal to, substitute the value here. Z1 value is 1 by Z1 bar plus Z2 value is 1 by Z2 bar divided by 1 plus Z1 value 1 by Z1 bar into 1 by Z2 bar. That's equal to, we can take LCM. LCM here is Z1 bar into Z2 bar. Say Z1 bar into Z2 bar. Cross multiply this. So Z2 bar plus Z1 bar. The whole divided by, here also LCM is Z1 bar into Z2 bar. So Z1 bar into Z2 bar plus, if you cross multiply, So you will get here 1. So Z1 bar into Z2 bar, here also Z1 bar into Z2 bar, we can cancel these terms. You will get Z2 bar plus Z1 bar divided by Z1 bar into Z2 bar plus 1. I am exchanging the value, that is Z1 bar plus Z2 bar divided by 1 plus Z1 bar into Z2 bar. We can write this term. So modulus Z1 the whole bar plus Z2 the whole bar we can write together. So Z1 plus Z2 the whole bar divided by 1 plus Z1 bar, Z1 into Z2 the whole bar. Modulus. Use the modulus here. That's equal to, so we can take Z1 plus Z2 divided by 1 plus Z1 into Z2, that's equal to take the whole bar, that is equal to Z bar. So Z is equal to Z bar. So this is the real number. We have the property. So Z is the real number. So write the question. Z1 plus Z2 divided by 1 plus Z1 into Z2 is a real number. So you can write this term as, we have separately in the numerator and the denominator, you can write this as whole term. So this value is Z value, so we can write Z bar. So Z equal to Z bar, we have the property I have given earlier. So Z is a real number. So this question is a, so show that Z1 plus Z2 divided by 1 plus Z1 into Z2 is a real number. So this is the answer. So let us note the homework problems. Homework. Exercise 2.5. First question, first, third and fourth subdivision. Do it as homework. Thank you.